This is trigonometry, section 4.7, and we're going to be talking about inverse trig functions today, meaning how do we find the angles? So if you know the sine of an angle or the cosine of the angle or the tangent of the angle, how can we find the actual angle that it's referring to? And your book definitely goes through the assumption that you've learned some of this stuff before, so that's why we covered in that pre-review the restrictions that we have set up for the inverse functions, because they want you to really start out by being able to graph some of these things. So let's start with our inverse sine function. So first of all, let's just remember that sine looks like this. Remember, at the origin, it starts out at 0, 0, and then at pi over 2, it jumps up to 1, pi back to 0, and so forth. And so sine is a function. We know it's a function because it passes the vertical line test. Remember the old vertical line test? As long as I only hit the function in one place, we can refer to it as a function. So now the question becomes, does sine have an inverse? Well, if we remember back from pre-calculus, in order to have an inverse function, it must pass the horizontal line test. Yet when I draw a horizontal line here, I hit sine in two separate places. So that tells me sine must not have an inverse function. We can just kind of go on our merry way and be done with it. Well, to be honest, what the mathematicians have done is we need to be able to evaluate and figure out angles. So in order to say that sine does have an inverse, we are going to restrict the domain. We are going to say the domain for sine is between negative pi over 2 and pi over 2. So that is the domain restriction for inverse sine. And we talked a lot about these, right? We talked about how that makes sense on our coordinate planes. If you think about your unit circle, up here, sine is positive, and down here, sine is negative. So therefore, we're going to cover all of our bases by including the fourth quadrant and the first quadrant. So that's another reason why sine is restricted to those two quadrants side by side. So here are kind of the restrictions that we have set up, and then we need to really figure out how does that correspond to the graph itself. So we're going to get some practice by actually graphing this on the coordinate plane as part of our first example. One thing to remember is that your book really likes to use the term arcsine. The arcsine, it really comes from the idea of a central angle with an intercepted arc on a unit circle, so that's where arcsine comes from. I know we've predominantly been using this because it really looks a lot like the inverse function notation that we've seen before. Your calculator, Desmos, all use this one. Your book tends to like this one. So this is Desmos and our calculators. We really just have to be able to use them interchangeably, and we got to make sure we know that they mean the same thing. So here's an example of the graph of the inverse sine. And some of this may look a little bit crazy, right? Where are these numbers coming from? We're going to graph this together, this exact thing. We're not going to transform it. We're not going to do anything crazy to it. We're literally just going to graph this. We're just going to do it together. So there's our, in the little box, you have a little summary that kind of goes over this, and we're gonna get to where those come from. But first, let's make sure we know how to calculate some of these things, how to figure these out. So I encourage you, get out your unit circle, but then also just have your calculator on hand. I know that I want us to try to find these without using a calculator, but that's always something that you can use on a test. So we're gonna think about what angle on our unit circle has a sine of -1/2. So looking at your unit circle, figure out, okay, what angle has a sine of -1/2? Well, it's 330 degrees. The problem is that does not meet with our domain restriction requirement that it has to be between -90 and +90. So therefore, I find a coterminal angle that is, meaning I subtract 360 degrees. So my answer is -30 degrees, or if they want it in radians, -pi/6. right? Keep that unit circle out. So what angle has a sine value of square root of 3 over 2? And it's 60 degrees, or pi over 3. And then our last one, looking at our unit circle, is there any angle that has a sine of 2? There is not, so therefore it does not exist. It is outside of the domain of our arc sine, of our inverse sine function. So what does that mean to really be outside of the domain? Let's go ahead and graph. And notice I know that you hate that we don't put in the xy coordinate points, but we're going to do that together. Before we do though, before we graph arc sine, I want us to think about the sine function. So let's just think about y equals sine of x. We're going to make a little table of values here of y equals the sine of x. And we'll just do a couple, we'll do some negative ones. So like negative pi over 2, negative pi over 6. If you still have your unit circle out, that'd be a good one to look at. And then pi over 2. All right, so looking at your unit circle, look at negative pi over 2, which is the same thing as 3 pi over 2. What is the sine value, meaning the y coordinate on our unit circle at negative pi over 2? Well, it's negative 1. Now look at negative pi over 6, which is the same thing as 11 pi over 6. What is the sine value at negative pi over 6? It's negative 1/2. All right, what is the sine value or the y coordinate on your unit circle at 0 degrees? It's 0. All right, same thing, pi over 6. Look at pi over 6 on your unit circle. Find the y coordinate, which represents sine. It is 1/2. And then look at pi over 2. What is the sine value at pi over 2? It is 1. All right, so here are some coordinate points that are part of sine. Now, in order to graph arc sine or inverse sine, however you want to call it, all we do is remember how inverse functions are related. We are going to swap the x and y's. So instead of this coordinate point being negative pi over 2, negative 1, it's going to be negative 1, negative pi over 2. Then we have negative 1/2, negative pi over 6. 0, 0, same one there. Then we have 1/2 pi over 6 and 1 pi over 2. So therefore, on my x coordinate, I just want to go up to 1 and down to negative 1. And on my y-axis, I actually want to go up to pi over 2 and down to negative pi over 2. And then I'm going to have in between our pi over 6 and our negative pi over 6. So I'm going to go ahead and graph these coordinate points. So I plot right there. Then I go ahead and plot negative 1/2, negative pi over 6. Then I do negative 1, negative pi over 2, 1/2 pi over 6, and then 1 pi over 2. Now it should have a bit, it's not just a straight line, it should have more of a curve to it. So it should look a little bit like that. Do your best there. But that is where the inverse sine function comes from. So this is why when you look at this and you say, okay, what is the domain of our inverse sine function? Well, our domain, looking at our x-axis, it goes from negative 1 to 1. What is our range value? It goes from negative pi over 2 to pi over 2. Kind of makes sense, right? Hopefully. So let's go ahead and remember, right, that we want to talk about all of the functions. We've just been focusing right now on sine, but let's remember there's also cosine and tangent. So what are those restrictions? At the bottom of your note packet there on that page, you'll see here are all of our restrictions for our domain and our range for arcsine. So here's where we can see, okay, for sine, our answer had to be negative pi over 2 to positive pi over 2. For cosine, 0 to pi. And then for tangent, negative pi over 2 to pi over 2. Now you'll notice here for tangent, we're not including negative pi over 2 and pi over 2. The reason being, at negative pi over 2 and pi over 2, tangent is undefined. At negative pi over 2 and pi over 2. So therefore, we can't include them within our range. Just something little nitpicky, but remember, your calculator will give you an error if you try to evaluate those. On the next page on your note packet, it has a nice picture of all of these inverse functions, as well as the domain and ranges. I'm sorry, it doesn't show here on my screen. I wonder if they're hidden. There they are. They're hidden below there. There's our domain and our range value. That should say a pi. Let's see if I can move that. Just type in pi. So there are the domain and ranges, and they're very helpful as you start evaluating some of these things to try to figure out, okay, is it in my domain? Am I allowed to evaluate this type of thing? All right, let's keep that unit circle out. Okay, we're going to keep that unit circle out and see if we can evaluate these. I want to find an angle on my unit circle. So what angle has a cosine of square root of 2 over 2? And my answer, right, 45 degrees, pi over 4. All right, now I know on our unit circle we do not have tangent, but remember tangent is sine divided by cosine. So looking at your unit circle, think about what angle is going to give me a tangent value of 0. Basically, we want to make sure we have a 0 in the numerator, but make sure there's not a 0 in the denominator. So you want a sine value of 0, a cosine value of 1, and that happens at 0 degrees, 0 radians. Look, thinking again, right, we want our sine value and our cosine value. We're trying to find what angle has a tangent of -1. We want our sine and cosine values to be the exact same, but one of them be negative. That happens at -45 degrees or negative pi over 4. Which is really, remember, it's at 7 pi over 4, but we have to get into the negative space. We have to use those restrictions because tangent is also restricted to be from -90 to +90. And remember, I don't include 90s in there. It should be just greater than. Okay. So now we do want to evaluate. Sometimes, especially when we're solving word problems, we're going to get answers that are not nice and round on our unit circle. So let's go ahead and find these values just using our calculator. Now, if you do not see a degree sign, notice these first two do not have a degree sign, that tells me I need to be in radian mode. So unless you see the degree symbol, you want to make sure that you're in radian mode. So for arctangent, I do second tangent on my calculator, -8.45, and I get out approximately, let's just round to 2 decimal places, -1.45. My next one, I want the inverse sine, and I don't see any degree symbols, so I'm just going to type it in as is. And I get out approximately 0.23, just round to 2 decimal places. And last but not least, arc cosine. Remember the domain of inverse cosine is -1 to 1. 2 is outside of that, and your calculator will give you an error. This here does not exist because it is outside of our domain. So our last bit of everything here is really, let's take this up a notch, right? We're going to take some of this information and take it up a notch, and we're going to do composition of functions, okay? Here's how we do it. I think it's a little bit easier if we do the examples together, and hopefully it will make sense. So when you have tangent and arctangent, or tangent and tan to the -1, remember, they cancel each other out. So all you can say is, for the most part, when you see them side by side, you simply cancel them out. But the first thing you have to make sure, am I getting a value in here that I am allowed? Is -5 in the domain of arctan? And if we're not sure, remember, you've got this picture back here. Let me go back to it, where we define our domain. So looking at arctan, the domain is all real numbers. So I can plug in any number I want for arctan. So that tells me, yes, it is. So because tangent and arctangent are inverses of each other, they cancel each other out, my answer to this question is just -5. All right, for our next one, these two should cancel out, but I have to ask myself, is 5 pi over 3 in the domain of sine? Well, my domain of sine is all real numbers, so yes, it is. Now, the problem is 5 pi over 3, what is a coterminal angle? Angle is -pi over 3. So yes, this exists. Yes, you are allowed to do this, but the answer that you're going to get out is what's in the restricted domain of arcsine. It's going to give out -pi over 3. And you can check on your calculator, right? Maybe you want to convert these into degrees rather than radians and work with them, but you will get out a negative answer rather than it just being 5 pi over 3. All right, our last one is pi in the domain of inverse cosine. Well, let's go back to our pictures over here. So here's our domain, here's arc cosine, inverse cosine. Now remember, pi is 3.1415, yada, yada, yada. That is outside of our domain. So therefore, I am not able to evaluate this expression. It is not. So our answer is that it does not exist. And these are tricky questions. Like you don't really show a lot of work with these questions. You really just have to be able to walk your way through it, ask yourself these questions, check on your calculator. If you get an error at some point, don't second guess it. An error is probably telling you that it does not exist. All right, let's go ahead and move on. Now, when you get to these types of questions, they are still composition questions, but notice instead of me having tangent and then arctangent side by side, I have tangent and then arc cosine. So what I recommend is to draw a triangle, draw a picture. Let's just go ahead and tackle this one at a time. And when we talk about composition of functions, we work from the inside out. And by composition of functions, I kind of mean this. Remember this in pre-calc? We work from the inside out. So we're going to say, okay, I'm going to draw a picture of a right triangle, always right triangles, and the angle that I'm interested in, let's say it's this angle down here, right? We always use theta, has a cosine value of 2/3. So that tells me, right, I am in quadrant 1 because my tangent value is positive. And in quadrant 1, that's my restriction. I'm either up here or down here. And when it's a positive answer, I'm up here in with cosine, I'd be over here or over here. We're going to be in quadrant 1 because cosine is positive. Now I need to figure out the tan. So I've drawn my picture for arc cosine. I'm saying, okay, here's your angle. Your angle is right here. That is the angle that we're talking about. Now from this, I want to find the tangent of that angle theta. So in order to do that, right, I need opposite and adjacent. And right now, I do not have my opposite value. So how do I find it? Good old Pythagorean theorem. 2 squared plus our opposite side squared equals 3 squared. So I get my opposite side squared equals 9 minus 4, which is 5. So I get that our opposite side is the square root of 5. Therefore, my tangent value for this theta is opposite over adjacent, square root of 5 over 2. All right, let's do another one. We've got arc sine of an angle is negative 3/5. So that tells me that it is down here in this quadrant. So right here is my theta angle. The sine value is opposite over hypotenuse, and this is the negative part here. And look at that, right? We have a 3, 4, 5 right triangle. That helps us out a lot. So I want to say, okay, what is the cosine of this main angle that we have identified? Well, cosine is adjacent over hypotenuse, 4 over 5. All right, our last example is we're going to work with some algebra. This is, again, starting to get us ready for Unit 5, where we start working with sine, cosine, and tangent in a very algebraic way. So we're going to go ahead and say, okay, write an algebraic expression that is equivalent to this whole thing. And it looks very similar to what we just did in our last examples. So I recommend you draw a triangle. So let's go ahead. We have a triangle here. And it doesn't matter as much about drawing it in the coordinate plane because they're telling us that our x value is positive. It's somewhere between 0 and 1/3. So we've got an angle theta, and it has a cosine value, which means adjacent over hypotenuse of 3x. So that tells me if the cosine of theta is equal to 3x, I'm going to write it as 3x over 1. That tells me that my adjacent side is 3x, and my hypotenuse side is 1. Once I have this drawn, I want to figure out what is my missing side. So I'm going to go ahead and do the Pythagorean theorem. I've got 3x squared, we'll just call this side b, plus b squared equals 1 squared. 3x times 3x is 9x squared. I then subtract 9x squared. So I get b squared equals 1 minus 9x squared. I then have to take the square root. So this missing side over here, it's ugly. It's the square root of 1 minus 9x squared. I now have identified all 3 of my sides, and I want to know what is the sine of this main angle theta. Well, it's opposite over hypotenuse, and my opposite side is 1 minus 9x squared, so it's 1 minus 9x squared over 1. Or you can just really write, right, just this first part here. That is your answer. I encourage you to try the next one on your own because it's the exact same picture. It's the exact same triangle. So I'm going to go ahead and draw it real quickly on here because we've already set up our triangle, right? Theta here, cosine is adjacent over hypotenuse. And then over here we have 1 minus 9x squared. Okay. So I make sure I drew the triangle in the same orientation. Now I want to figure out what cotangent is. Well, cotangent is adjacent over opposite. I was about to write hypotenuse, but it's opposite. Right? Tangent is opposite over adjacent, so cotangent is adjacent over opposite. So I get 3x over the square root of 1 minus 9x squared. And this just comes down to the whole idea I'm not allowed to have a square root in the denominator, right? So can we simplify this? I know these are getting pretty ugly. My final answer ends up being 3x times the square root of 1 minus 9x squared all over 1 minus 9x squared. Final answer. So that concludes section 4.7 in Trig.